We're on page 4 of my Google Doc, and this is labeled lecture MM03, mathematical modeling 03. You see the first sentence there, I just said, we have been working with mostly business-like examples, right? Large leases and huge number of income and things that are making you a lot of money. Though some may appear far-fetched, let's move to a personal finance example or personal finances example. This, I use my own actual numbers, right? So you can see right here that my other job, I do make $22.5 an hour. That's my gross income though, and then we're going to assume 14.27% of wages taken from federal and 7.88% of your wages taken from state. So obviously taxes, right? So this is example 1. And part 1, or first part here, it's going to be 2205x, where x equals total hours worked per month. And I mentioned this before, if you had written out just this 22.05x, of course I'm going to give you credit, yet if you have all this in addition, that ensures that I'm understanding what you're talking about. The unique thing this time is that I'm talking about taxes, right? Not percentages, you all know that already. Specifically taxing on your income, right? So it's not the usual where, hey, I work 100 hours, I multiply by 22, I get $2,200. It's like, nope, if you're here in the States, you got to get taxed. So if you notice, the tax rates are what is that? 14.27% and 7.88%. I already forgot what this number was. I think I have this written out yesterday from yesterday's lecture. Yeah, here we go. All right, this is a total of 22.05% in taxes, right? However, if you're getting taxed 22.05%, how much do you take home, right? You take home as most of you have probably heard before, you take home, what is that, 77.85% of your income, right? 22.05 is your hourly rate. You multiply by so many hours. I looked this up online for federal and versus New York state, right? So that's federal on top and New York for the 7.88. It's an approximation, right? This doesn't include if you do stock investment, retirement investment, 401k, all that jazz, or health benefits, right? Pre, post-tax deductions. But the idea is that if you're taking home 77.85% of, right, of what? Of this, you can actually change that to a decimal, right? So you now have 0.7785, and you're multiplying that by your hourly rate because you're not getting the full hour, working full hours, sadly, but you're not getting a full hour of pay. So this is the piece that you want to go in your model. And again, it's not nothing terribly different. It's just that you're now incorporating taxes, which we have not talked about prior. Okay. Part 2, it's a lease. I worked backwards on this one to figure out what my monthly.
Alexa, wake me up at 10:45 a.m.
Alarm set for 10:45 a.m.
Sorry.
That's okay.
It was just like how I talk to my Alexa because I needed an alarm for another thing.
No, that's fine. At first, I thought you were talking about Alexa in our class, Alexa. That's why I was like,
Oh no, I have an Alexa in my room.
gotcha. Okay. The lease for part 2 right here. Again, I just use my actual rent. My rent is approximately $10.95, almost $1,100. So I worked it backwards so that you guys can solve an annuity here. So present value annuity, you're solving for the monthly. The numbers plugged in looks like this: 241,700, 0,357. And again, I got that fixed rate, if you're curious, for a 30-year mortgage online as well. So just making this a little bit more relatable if we were going through day-to-day operations here in the city, or if you're within the 5 boroughs, or if you're in Long Island, Jersey, maybe not Jersey, Long Island, upstate. Okay, so there it is for the lease. The answer, which I did for my other class's lecture, comes out to, I'll write this in a different color, 1,094.81. So if you're still having trouble calculating these, arriving at these answers, I will take the moment right now, give you 30 seconds or so to punch it on your calculator, be familiar. Obviously, part 1 didn't have any proper calculations, but I'll give you a moment to just take a look at that, and we'll just move on. All right, that should be good. And then last but not least, the third bullet. In my last class, I didn't write it out, but I'll just write it out here right now. You're basically putting away, AKA saving, $200 per month into some kind of unknown savings account. And you notice that the number is just there because it was done on purpose. Excuse me, there was no proper calculation or anything of that nature. It's just there for you to use as reference. Now the model, right? The model itself for this problem, your base model, that's the way to think of it, right? Is the following. It's 0.7785 times your hourly rate. You're subtracting off your rent for the month, and you're subtracting off how much money you're putting away per month as well. Remember, even though we're talking about hourly rates here, this whole scenario is per month basis, right? And again, let me write base model here as a nice reminder. Okay, and we can now answer the follow-up questions. So the first question right here. Question number 1. It asks you, assume a normal working week of 40 hours, right? Full-timers in the US at least, working 40 hours, whether it's an hourly wage or a salary wage, you basically are clocking in more or less 40 hours at a time, and 4 weeks in a month, how much would be made in a month? Here they're telling you that you want X to be equal to 40 hours per week for those 4 weeks. So it's a total of 160. And that goes into just your X right here. So again, this type is a calculating follow-up question because you're simply taking your model, whatever it is, and you're plugging in numbers to get some kind of result. 10, 9, 4, 81 plus 200. So that's the setup. This answer, again, I have it already in advance. So this one, I'm just gonna write down the answer and box it for you guys because it's just adding and subtracting and multiplying. 4174 positive result. Or if we're thinking about it in terms of this problem, what this is saying is that if you work a full 40 hours for 4 weeks in a month, you're expected to pay rent and put money away in your savings account. You have about $1,400 left in quote unquote play money, but it's not play to spend frivolously, right? Now you got to worry about buying groceries, buying food, maybe eating out, maybe having a drink or two, maybe an unexpected expense. Or so the first row or the model itself takes care of your fundamental things that you need to do in life, right? How much money you're making, and then how much you got to set aside for rent, how much you got to save aside for savings, right? But this 1451, it's not allocated in such a way. So if you're thinking about personal finances, now you got to budget yourself. What can I do with 1,400 and for the remainder of the month, whenever that is? So, little things to think about that way. Question 2, it asks you now, how many hours would need to be worked to break even? So that's a break even question, right? And as always, break even, it's always $0 equals your equation, whatever the equation is, in this case, the model. And that $0 is very critical because people, again, solve for this. Even though I asked you how many hours would need to be worked, people end up solving, they get a number, and then they accidentally give the fact that the answer is in dollars or something. But I always say, if you started with $0, how could you possibly have made money from solving this break-even point? So we're bringing this back right here, the base model. And we're solving for X right there in black, right? The only thing that's different about this one's relatively simple, is that you have to distribute the number right here. So I did this calculation in advance as well. I said that these two numbers added up, and then they have to go to the other side where the 0 is. So that implies we have 12,9,481. Okay, good. Next, I distributed, or AKA multiply these two. This gives you a result of 17.165925x. And of course, you divide both sides by that same number. And this implies what? 75.4290 blah, 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 blah hours. But remember, we always round up. So then your proper answer that I would always expect is you must work 76 hours to break even. Now, what does that mean in terms of our problem, right? In terms of personal finances for this particular problem? It means that if you work 76 hours at this hourly rate of $22.05 and you have your taxes taken out, that means you actually make rent and make your savings account deposit successfully. But then that also means that you have squat to spend after those two expenses. And you can see the major difference, right? 160 hours for full-time, right? That's working your full 40 hours for the whole month, hypothetically. But then all of a sudden for this example, you found out that in a month, if you work 76 hours, you have enough for just the bare minimum. So again, most of us are working on an hourly wage right now. So this gives you an idea of how you can plan to work essentially. Obviously, you always want to work the maximum, but sometimes things happen, right? You want to take vacation, you have to take care of someone, you have personal things come up, you have other obligations, can't always work, right? So these are things to keep in mind as well. The last question is actually a little bit of a review, but I don't formally introduce it into the model. I just give you kind of like a baby step into it. I go, hey, suppose for the second month, you want to take 15% of your income to deposit once into a mutual fund, but you have two options, right? And then they are 4.23% compounded monthly or 4.26% compounded quarterly. Which account should be used? Question mark. That first part of the question uses the effective interest rate. So I'll say that right here. I'll do it in a different color. First part of question. And remember, effective interest rate was the last thing that we had on our first exam. And again, I know I didn't get a chance to hand those back to you, but your grades are up and there's a copy of the first exam on Blackboard as well. If you happen to have your formula sheet in front of you, right, your paper, your folder, your notebook, or whatnot, that again is the fourth row of our formula sheet. So it's 2 ones. So here, I'm just going to color code in black here for the first one, option 1. That tells you 4.23% compounded monthly, right? Since you know it's a compound period, you know it looks like this. You just have to convert the percentage to a decimal. I've had students forget that. That was bad. And then remember the compound period is applied there. And then for option 2, you do the same exact thing, but you just have to adjust the interest rate because, well, it's a different option, right? 1 plus 0.0426 minus 1. And this time the compound period is quarterly. I have these numbers answered out in advance, so let me write them out. The other thing to recognize is that I didn't get to talk about this too much. When I saw first exam from not just your class, but any other class, they would set up this correctly. When I say this, I'm talking about these parts. These would be done correctly, but something went super haywire on the calculators because one of the calculations would be correct and the other ones would be super off, right? You just want to be very careful when you're doing this. And remember, for effective interest rate, you're going to always pick the higher return. So that would be option 2 right here. And I'm going to write here as well in purple, pick highest return. If it's a nice little reminder, the reason we use effective interest rate is when you have not only 2 different interest rates numerically, right? 4.23% for the first one, 4.26% for the second one. It's also when the compound periods are different. So when they're different, you can't just simply quote unquote multiply up, right? You have to adjust, and that's what this allows you to do, which means that the second month's model now is the following. So this first part right here that I wrote in the pink right there, that first sentence, that's just a matter of review. I bring it up because there are review problems that I have not assigned, but they're there for you to work in the appendix section of my textbook that allows you to practice. And I may have talked about effective interest rate within the model. All right, if you look at the base model, remember, which was this right here, base model. We're going to take that same exact model, but now we have to take 15% of our income. Well, what's income? Income was this portion right here, the only thing that's making us money, right? That product or that multiplication of between those two terms. So how do you take away 15%? Well, you recopy it down. Everything that you had before. Subtract off your numbers, your expenses, right? 1094, 81 for your rent, 200 for your savings account. And now we have to subtract off 15% of our income. And again, our income is this portion right here. This is income. So whether you rewrite that number or you just write the word income because you properly labeled it, either answer would be correct. But the idea is that you're supposed to realize that this piece in this light green or this puke light green is the same term that's supposed to go inside these dark green brackets, 0.15, because you want 15% of your income. And the only thing that makes you money is this leading product of 0.7785 times 22.05x, right? What questions do we have for this first example, whether it's any of the follow-up questions or the model itself? Let me see if anyone typed up the question too. No, but I'm going to tag these people that are here. Where's Asia's name? There it is. All right, cool. So for those that trickled in, no worries, I got you. Okay, let's move to the second example. Again, if you don't have it pulled up already, if you came in after, make sure you have the Google Doc. We're on page 4. It's not labeled page 4, but at the top of the page it says lecture MM03. So it's the fourth modeling lecture that we have. And since we were just introduced to summation to be part of our model, I said, hey, let's do another example of that nature. So here's example 2 for the day. We're going to finish after this. It's asking now you're personally in charge of some kind of website, right? And the philosophy here is that it's a website, you're not selling anything, it's not an online retailer. It's just, you have a blog, for example, and you deliver information, and because of the number of views that you have, it creates some kind of monetary income for you. So that's the scenario here. Part 1. And again, if it wasn't clear on Wednesday, right? This aspect where you're reading it, I mean, I'll read it out loud really quick. It says your web page makes a monthly post. You expect the first day the post to be reached by 100 people. Your research suggests when a post is seen, it is shared to 2 new people the next day and thereafter. So that second sentence, sorry, technically third. Your third sentence, when it says your research suggests or something suggests your growth rate, you know that's a summation immediately, okay? I'm telling you right from the bat right now that if you're looking at the homework or these examples that we do together, or even the examples in the appendix section for the review for the final, it's all there. They all follow that same verbiage, if you will. That's my clue in to let you know what's happening. And then it lastly says you make $0.0023 per post viewing. So remember, if it helps, I would write things down. Similar to that of when we were first learning equations, right? that your initial startup is that you want that post to hit 100 people. Your growth factor is by 2. And your monetary or monetization, and I'll just put in parentheses here, if any, because sometimes I write it without it making money, is this really small number of 0.0023. So if you remember the format, if you will, of how I had you label this, it's alpha times beta to the I minus 1, right? Which implies what? Alpha is always your initial. Why is alpha initial? Well, if you don't recall, alpha is the first letter of the Greek alphabet, so just remember it that way. A for first, A for alpha, A initial. And then you know that your growth is how it's growing. That's why it has the number with the exponent. So that's what that looks like. Now, if you're going to put this in the summation, all together now, it will look like this. I equals 1 to n, right? That's the summation that tells you not only to calculate, but to add your results up. And then now you, different color, you take this term here and you plug it in. So let me just color code that really quick. 100 times 2 to the I minus 1. And the last thing is, remember, you're making money, so you have to multiply by 0.0023. I wrote that in an angle because I didn't have enough room. Nope. There we go. Right, so this piece is going to go into your model. The second question tells you that you have a form of a lease, but basically it's like having your own domain name, right? And let me just write out what that looks like. So it's $10,000 0.0123 1 minus 1 plus 0.0123. And if you do this, and I said 50 years, so it's minus 600. Let me write this in a different color here. It's equal to $22.32. So you're going to be using this piece as well for the model. Let me do this in a circle here. Okay, so here are your two pieces, components, aspects of the model. You put the model together and you get the following. You get the summation. And you get the numbers 100 times 2 to the I minus 1. And remember, it's making money, 0.0023. You're subtracting off what it costs to maintain your domain name per month. Now, I'm not sure if any of you have a website, but just a nice little side note. If you have a domain name of some sort, most companies have you pay per year, right? So it's a little bit unorthodox to pay per month. However, because this is an example involving monthly situations or monthly scenarios, I've broken it up that way. It's a little something unorthodox because I have a domain name, for example. I pay that only once a year. I don't pay it per month. This is just to fit our mold of monthly situations for our models, right? Now on to the questions. I kept this one short because you have the longer version on Wednesday. This is just to get used to writing out summations. It's asking for part 1, how much was made in the first 4 days? And then the second question is asking how much was made on the 10th day. Now, when you read those, I know they seem very, very similar, but they're completely different. And I'll tell you why right now. Question 1 is asking for the first 4 days. I'll write that out again. first 4 days, that's unique because that implies that you have to use the summation, right? If you're asking for the first 4 days, that means you're not asking for only day 4. Doesn't mean you're asking for only day 1, but everything in between. So that means that you rewrite your summation not to an n, but a 4 at the very top, because you're only going to the 4th day. And then your equation is this expression right here. And then this is going to equal to what? Well, it's going to be equal to that same exact expression written 4 times. And anywhere you see that I, you have to replace it with whatever number you're on. So since we're starting at 1, that I gets replaced by a 1. Minus 1. And then once you're finished plugging everything in, you separate it by a plus sign. Why plus sign? Because this sigma notation indicates that after you plug in your number, you're adding your results. So then you do it again. 100 times 2. What comes after 1? 2 does, minus 1. And then you end with the plus sign. Then you do it a 3rd time. And then you do it a 4th time. 100 times 2, 4 minus 1. Now there are graphic calculators that can do this a lot quicker. Also though, realize that if you end up doing this type of problem on the final, I'm not asking you to do 10 days, the first 10 days, right? That first is the key word as well, because it becomes tedious. I'm not gonna have you do this for 10 stupid days, right? I'm just gonna have you do it enough so that I can see that you understand what's happening. So what are the answers here? This becomes 100. This becomes 200, then 400, then 800. You're adding all those results together. So in total, you see, or 1,500 people see your monthly post, right? See your post in the first 4 days, which also implies that you multiply this by, remember 0.0023, which goes in front of the summation here. That implies that you made $3.45 for the first 4 days. So again, this problem is special in the sense that it talks about first 4 days, which means that we use a summation. Question 2, when I ask for just a 10th day, right? Just. I didn't write the word just in the problem, of course. I just wrote how much was made on the 10th day. But to emphasize just 10th day, that implies you have no summation because you're not adding up a series of days. It's just a single day. So you use 100 times 2, and you plug in 10 immediately, and you see there's no summation. It's just this calculation. Okay, I did this in advance, and this is equal to 51,200 people, or views, or people that see your posts. And this is just the 10th day as well, which implies that you made, again, multiplying this by 0.0023, again, that number was given to you, you made $117.76. Now, if I had if I had more follow-up questions after this, they would talk about manipulating the model, right? What does that look like? That looks like where for example, on Wednesday's class, I said, hey, what would happen if the growth or your research suggests that more people actually see it? You got more traffic, right? So say it's not shared by 2 new people the next day, but say it's 4 new people. How would that change? right? I know it's not written here, but let me just type it out really quick and then just show you an example. We'll just do one more follow-up to this question and then make sure that you guys understand here. So suppose for the second month, you found that there is actually more traffic on your web page. Research is now suggesting that for each person seeing the post, it reaches 4 new people the next day. Soon 100 people see the post. So again, this wasn't planned, but I just wanted to give that last oomph to make sure that people understand. So again, this is a follow-up. And I wrote it onto the Google Doc so you can see it update immediately. But I'm asking now, hey, suppose basically in a nutshell, your 2 is no longer the same. But now I'm telling you that it doubled, right? Doubles to 4. Doubles to 4, right? What does a second month model look like? And I said, assume that 100 is the same. So what we did on Wednesday was more of this model manipulation where you have the same exact thing written out. It's just that you have to adjust the proper numbers appropriately so that you can show the correct growth. This is now times 4 to the I minus 1. Close your parentheses. And then we had, remember our lease, you can't forget that, of $22.32. So again, I just wrote this question on the fly just right now. So don't worry if you didn't catch it right away, but it is updated on the Google Doc. And I just wanted to show you that the first 2 questions were more of the calculating, not even more, they are of the calculating sense. And this one is more of the manipulation sense, okay?